Anybody here remember the Buffon-Laplace method of estimating pi by dropping needles?
I know. You take a piece of paper and inscribe a circle in a 2x2 square. We then drop a bunch of needles on the paper and compute the ratio between the number of needles that land in the circle and the number of needles that land anywhere in the square. We know that the area of the square is 4. We also know that since the radius of the circle is 1, the area of the circle is pi. Therefore, if the needles are truly dropped at random, and if we drop enough of them, pi should be roughly equal to 4 times the ratio of the needles in the circle to the needles in the square.
Perfect. Now I need a volunteer to help me with the experiment.
I'll do it. Pick me.
Thank you. Now, what I need you to do is take this picture and hold it in front of your body. All right. Buffon-Laplace used needles, but this is way more dramatic. So we'll just see how many of these arrows land in the pie. Now, I wouldn't do that. That's way too dangerous. Let's do this instead. You give me the paper target, and I'll give you this more substantial one to hold. But I'm not going to miss if you're this close. So let's have you go a little further back. Why don't you walk behind the seats? Yeah, this is better. I'm not so sure I'll hit the target since I'm not used to shooting uphill. Please try not to move for your own safety. Well, she's not getting an A. I suppose it'll work just fine if we put the target on a chair. Okay, let's see what value we get for pi. Using the equation we saw in lecture, we see that pi equals 4 times 6 over 6. Well, even a Harvard student can solve that equation, so we know that pi is exactly 4. On the other hand, that's really only one trial of 6 arrows. So let's try a few more flights just to be sure. Okay, that's 6 trials, and for each trial, pi came out to be 4, so the standard deviation is 0. So we know with high confidence that pi must be exactly 4. Yes?
I believe your math, but I seem to recall that this kind of analysis only makes sense if the trials are random and independent. Is either true here?
Very good point. They do need to be random and independent, and in this case, they're probably neither. But I see you have a tool that will help me fix that. Can I borrow your scarf? Spin me around a couple of times. Thank you. And now if you could walk me to kind of the middle of the room and hand me my bow.
Stop.
Why?
There's students there.
So, oh, all right, makes sense. Could you point me in the general direction of the target?
Yes.
Kind of like this?
Yes.
Thanks. How would I do?
Okay if pi were 0.
Oh.
Maybe we should just use Python to build a Monte Carlo simulation instead.